All right, now that we've talked about radians, we're going to get going on what we really want to do with them, which is do trigonometry. And so, now that you know what something like pi over 3 even means, we're going to try to find the value of sine of pi over 3. And so I'll tell you, in this class, we're going to draw reference triangles to compute values of trigonometric functions with radian inputs like the ones we just looked at in the last video. And so if you don't know about pi over 3, then that means, you're not up with the first part of this lesson. So you need to go back to the video about radian measure of an angle. And, I'm sure you can click up at the top there, and it'll take you back there. But, assuming you do know about pi over 3, what you need to know is that pi over 3 is equivalent to 60 degrees. Okay, so we're going to go up 60 degrees from 0. If 0 is there on the positive x-axis, up 60 would be about there. Doesn't have to be perfect. Okay, and then we're going to draw a reference triangle. So that's going to involve going back to the x-axis, always back to the x-axis. Okay, and then we've got ourselves a special right triangle. Okay, we're going to label the side lengths. Remember, for 30, 60, 90, for our reference triangle at least, the hypotenuse is 1, the short leg is a half, and the long leg is root 3 over 2. So if we're finding the sine of pi over 3, what we're going to do is we're really just going to take opposite over hypotenuse from that reference angle of 60 degrees. Okay, so that's going to be sine of pi over 3 equaling root 3 over 2 divided by 1. And it's just going to be root 3 over 2. So to recap what we did right there and to give you a set of steps for, evaluating trig functions on your own here in a few minutes, first we found the location of the radian measure of the angle on the circle. Okay, so we found theta on a circle. Then we drew a reference triangle. Okay? And then from there, we just used SOHCAHTOA. Okay, so it's a three-step process, and we're going to go with this three-step process every time, even when they get, more complicated than sine of pi over 3. Okay, so if we're confronted with something like cosine of pi over 4, okay, first step, find pi over 4 on the circle. Okay, pi over 4 is equivalent to 45 degrees. So I'm going to go up 45 degrees from 0. Okay, remember, positive angles rotate counterclockwise. Okay? And so that'll be a 45-degree reference angle in there. Okay, then we're going to make ourselves a reference triangle. So we're going to go from the point where the terminal ray intersects the circle back to the x-axis. Always the x-axis. Okay. There. Kind of the two legs and the hypotenuse. Now we go back and kind of label the side lengths. Okay. For our reference triangles, remember the hypotenuse is always 1. Okay. For a 45, 45, 90 triangle, the two legs are both root 2 over 2. Still visible to you. All right, so if I'm trying to find cosine of pi over 4, I'm going to do adjacent over hypotenuse. And it's going to be root 2 over 2 divided by 1, and that's root 2 over 2. Now, if they want me to find tangent of pi over 6, okay, we can do this. We're going to think, okay, what you got to know is what pi over 6 represents. You have to know it's a 30-degree angle, okay, because the whole circle is 2 pi, half of the circle is pi, and half the circle is 180 degrees. So 180 divided by 6, that's a 30-degree angle. So we draw what we think is a 30-degree angle. That looks believable, but I like to draw these a little bit more exaggerated, because the more exaggerated I draw this, the wider or taller the 30, 60, 90 triangle is, and the harder it is to get the 1/2 and the root 3 over 2 mixed up. I'll draw my reference triangle from going from the point of intersection back to the x-axis, always the x-axis. That's going to make a right triangle. And I'll kind of label the side lengths. This is a 30, 60, 90 triangle. I kind of forgot to label the reference angle, but I'm trying to do that. Okay, so that's 30 degrees. And, okay, for our reference triangles, hypotenuse always 1. For 30, 60, 90, the short leg is a half, and the long leg is root 3 divided by 2. Now, I'm interested in finding the tangent of pi over 6. So I'm going to take opposite and divide it by adjacent. So 1/2 over root 3 over 2. Now, okay, I'm going to need to simplify this, right, because there's going to be stuff that can cancel. I've got a radical in the denominator, so I'm going to keep the numerator the same, change the division to multiplication, flip the denominator, cancel stuff off, say that this is equal to 1 over the square root of 3. It still has a radical in the denominator, so I'm going to rationalize the denominator by multiplying by just the right form of 1. And that's where I'll see, I guess I don't need to write it twice. This will be equal to 1 times the square root of 3 divided by the square root of 3 times the square root of 3. So that's root 3 over 3. All right, now that's pretty much it. I'm going to do 3 more examples with you, but if you're feeling good about what I just said, go on and go ahead and do the homework. Whatever I'm going to be doing through here is not going to be anything really all that different. Okay, so for secant of pi over 6, same strategy. Start with the circle. Really doesn't have to be all that nice. Draw our angle. Okay, so I might point out pi over 6, that corresponds to a 30-degree angle. Okay, so we go up by 30 degrees, which is not really very far. And then I'm going to draw myself a reference triangle. So the legs will be right here and right there. Right, then I'm going to label the reference triangle, okay, with the reference angle, that's 30 degrees. And then hypotenuse is 1, short leg is a half, long leg is root 3 divided by 2. All right, secant of pi over 6 is 1 over the cosine of pi over 6. So what we're going to want to do first is find cosine. So cosine of pi over 6 is going to equal adjacent over hypotenuse, root 3 divided by 2. As a result, I can say that secant of pi over 6 is going to be 2 over the square root of 3. But in AP Pre-Cal, we need to have a rationalized denominator, so I'm going to go over here and multiply by just the right form of 1 and see that, okay, that's going to be 2 square root of 3 divided by 3. So that's secant pi over 6. All right, now here's one for you to try on your own. I want you to try to find the value of cosecant of pi over 4. So go ahead and work this one with a video pause, because I'm just going to bring in my work here in a couple of seconds, and you can check your work against mine and make sure you know what you're doing. All right, there you go. So first things first, I identify where on the circle am I. Pi over 4 is equivalent to a 45-degree angle, so I'm going to go counterclockwise 45 degrees from the positive x-axis. Draw myself a reference triangle, which I did in red, label the reference triangle, and then, if I want cosecant, I need to start with sine and then flip the fraction. Okay, I got root 2 over 2, I flipped that, rationalize the denominator, get the square root of 2. All right, now the last one I got for you is cotangent of pi over 6. And, I would do pi over 3, but I don't want it to work out the exact same way as tangent of pi over 6. So I'm going to give you cotangent of pi over 6 and just give you one more. Once again, I'm going to just bring in my answers here in a couple of seconds. So work this one with the video paused. Make sure you know what you're doing before you move on to the homework. All right, so there you go. After drawing a reference triangle and finding tangent and flipping it, I ended up with cotangent pi over 6 equals the square root of 3. And that's going to be all for this video. I think at this point what you really need is to just practice this a whole bunch of times. So, yeah, good luck with that. Enjoy, and thanks for watching.